My name's Isaac. I'm a data scientist. A little bit of background about me. My background's in theoretical statistics, used to teach in statistics, big R user, and about 4 or 5 years ago, a colleague of mine introduced me to machine learning. And I'm sure many of you are statisticians in the room. As a statistician, when I was first introduced to machine learning, I said, there's no way that computer scientists can get better prediction error than statisticians. And I reluctantly looked at these machine learning models and very quickly realized that in many situations the machine learning models were just beating the crap out of the statistical models I'd been using. And so I crossed over to the dark side, went into machine learning, and then gradually kind of became a data scientist and started working in consulting. I used to work for Quantium, a consulting firm down in Sydney that's famous for linking all the data from the biggest supermarket in Australia with the biggest bank in Australia. So you've got this kind of, we see all data set on the customers. So I worked on that for a little bit. And after that, started working for a company called Altus Consulting down in Australia. They're a data warehousing and BI company who also does machine learning and predictive analytics now. And what I noticed was, it's in the APAC region at least, not in Silicon Valley, but in the APAC region, a lot of the machine learning and predictive analytics stuff is very, very experimental. Okay, and there's not a huge amount of budget put towards machine learning and predictive analytics. There's not a lot of kind of executive champions for these sort of models. And that was frustrating because we were constantly trying to get buy-in. And sometimes we would, but more often than not, we were fighting an uphill battle. And gradually what I realized was that a lot of the value, I think that the industry as a whole, the analytics industry as a whole, overhypes the value in predictive analytics and machine learning. So I'm not saying there's no value in predictive analytics and machine learning, but I'm sure many of you have seen a chart like this before, the analytics value chain. So the idea being that companies have to progress through this value chain in succession. So starting with your data management. So as a company, obviously they have to figure out their data collection and storage and metadata and all of that. And then once that's sorted out, moving on to your routine reports. So either monthly, quarterly, it's weekly, daily reports of the key metrics and questions that the business needs answered. And then once that's satisfied, moving on to descriptive analytics, or what I sometimes call demand pull analytics. So when key people in the organization need to answer a certain question, the data should be available, and also a team should be in place to be able to answer that question and turn around the insights back to management. And then, based on this chart, and then and only then would you move on to predictive analytics and machine learning, so fancy predictive models. And so this is a chart that is widely socialized by a lot of consulting firms. I won't name names, but a lot of big name consulting firms, if you type in analytics value chain into Google, you'll see all sorts of variations on this chart. And it's great for consulting firms because businesses get in their idea that they have to work their way up this value chain in succession. But I think that we don't have to work up this value chain in succession. I think that, the first thing that I think is misleading is that somehow this business value axis seems to imply that there's more business value in machine learning and predictive analytics in descriptive analytics. And I think for certain businesses, that's certainly not true. For certain businesses, just asking basic questions of the data and then querying the data warehouse and packaging up the answer to that question well to management, I think that there's incredible value in that. So the reason I just go through this is I think that the data storytelling, the value in data storytelling has been forgotten. And that's why I'm so passionate about data storytelling and how we can do it well, because I meet a lot of analysts out there who are on their data science journey, so they don't necessarily know how to fit a gradient boosting model yet, but they're on their journey. And they feel like they're not adding as much value as the fancy data scientists. When in reality, they may, if they're engaged in the descriptive analytics, or what I call the demand pull analytics, they can actually add incredible value, especially if they can obtain domain expertise in the vertical that they're working in. So that's to give some context of where we're at. We're talking about data storytelling. Data storytelling is here in the middle of this so-called value chain, but I certainly wouldn't say that its business value is less than predictive analytics and machine learning. So I was just telling the organizers just then that the goal today is to give you some key new skills that you can take away in 1 hour in order to tell better stories with data. And we're going to cover 4 keys to what I think are the 4 keys that you need to tell a good story with data. I've noticed a few people taking pictures of the slides. That's totally okay. Do know that I'm going to upload the slides to the discussion wall, so you don't have to scramble with your camera and put it on high resolution. So let's start with the 4 keys to data storytelling. And the number 1 most important key is understanding the audience. The audience is the hero of your data story. What we want to make sure is that we're in the bottom third here. So when you present to an audience, what we want is for meaningful learning, meaning if we're talking about a PowerPoint deck, for example, the audience is absorbing and understanding everything on our slides. What tends to happen, particularly among highly technically trained people, is that the audience only gets fragmented learning because parts of the analysis are too technical. So the first thing I want to mention, how many statisticians do we have in the room? Any statisticians? Yeah, a few statisticians. I'm sure we've got some math people, physics, all sorts of backgrounds. One thing I notice is that statisticians and mathematicians and technical people tend to overcomplicate their analyses. Part of it is that we're used to more complicated metrics. We're used to the standard deviation. We're used to skewness and kurtosis and all of these various measures. And what I see a lot out in our client work is data scientists and statisticians using these more complicated metrics when they're presenting data stories to management or presenting the results of their predictive model to management. And I think you really have to be careful with that. Because whilst we might be used to measures like the standard deviation, the managers aren't going to be. So if I'm going to do a survey of CEOs in Singapore, for example, and I ask them to give me a rigorous definition of a standard deviation, I'd estimate that 1 out of 100 would be able to accurately define what it is. So we want to stick to basic metrics. We want to stick to counts, frequencies, means, ranges, max and minimums. But that said, if you're presenting to a bunch of data scientists, then go for your life. So that's the first thing. Understand the level of your audience. Think about the most appropriate storytelling medium for your audience. So PowerPoint decks are very common in business. I have a colleague that says power corrupts and PowerPoint corrupts absolutely. It has its fans, it has its detractors. Obviously, we've got shiny dashboards that we can now host in the browser. So think about those. We've got Tableau dashboards in the cloud and things like this. So just because your team's always done it in a PowerPoint deck doesn't mean you have to do it too. So think about, maybe your executive that you're presenting to wants to view your story on a Sunday morning on their iPad. Okay, so maybe some sort of shiny dashboard would make sense there. Okay, I talked about that. All right. Last thing we'll say about audience is when I say the audience is the hero of your data story, that's not just lip service. Everything about your data story, from its length to its visuals to its key takeaway, has to be chosen in the context of the audience. So very early on in the piece, say, who is my audience? What do they have a sphere of influence over? and then what story do they need to know. And try to compress it down to 1 or 2 key takeaways per slide. More than that, and people kind of go into analysis paralysis. So to illustrate this point, I'm going to grab some data. So here's some data. Obviously, I've set up a big Hadoop cluster for this data set. No, it's just that's the whole data set. And this is data on the Sydney to LA route for a certain airline. And we have the number of seats occupied and the number of seats available. So this number of seats available is just, you look at how many planes are flying that route, how many seats are on that plane, so how many seats were available to be purchased, and seats occupied were how many butts were actually on seats. And let's tell a story with this data. Now, the first question we need to ask ourselves is, firstly, is a visualization even needed? Because sometimes, we don't need to complicate things. Sometimes just a big summary statistic is going to, a well-chosen summary statistic is going to get the message across. We have 1, 2, 3 different variables. We have time, we have seats occupied and seats available. We've got, 13 rows there. No, we've got 11 rows there. So, that's complex enough, just complex enough for us to want a visualization. So we've decided that. But we need to know who the audience is. And we're making an assumption here. We're going to assume that we're consultants, and we've been brought in to look at this airline data. And we're assuming that the audience, the main audience is the chief operating officer of the airline. And that's really key, because the story that I tell to the chief human resources officer is a very different story to the chief operating officer. The chief human resources officer wants to know how many additional stewardesses and stewards and pilots are we going to need if we're going to do something about the fact that seats occupied is kind of getting close to seats available. Whereas the chief operating officer is thinking, how many additional planes do I need on this route? So right back at the start, who is the audience? What do they need? What are they able to change? Okay, so the chief operating officer wants a recommendation on whether to add additional flights to the Sydney to LA route. So that's the context. Okay, I've got the data here. I want to turn this into some sort of story that's going to inform the chief operating officer, do we need to add flights to this route? Okay, now, we've decided that a visualization is appropriate. Now we need to decide what visualization. And when I visualize data, I'm in one of 2 modes. I'm either in exploring mode or storytelling mode. When I'm in exploring mode, I just want to get the key insights out of the data. But I'm not that worried about the overall form of my visualization. When I'm in storytelling mode, I'm more thinking, what is the optimal visualization for this data for the audience to consume? So the first thing I'm going to do is just visualize this really quickly to get the key insights out of the data. And so I've gone with a clustered bar chart. Just because I've highlighted the data, I've gone straight into Excel and visualized the data. And the big problem with storytelling these days is that people produce something like this in Excel and say, oh, well, that looks okay, and just stick with that. Okay, but that's not a framework for choosing the right visualization. But this is really prevalent out there in the business world. Excel just makes it so easy to just kind of hover over and just throw it in. So if you notice a lot of bad data storytelling out there, and I certainly do, I blame Bill Gates, because he's made it so easy to just go in and just insert your chart straight away, and it kind of looks reasonable. So what I've got here is I've got a clustered bar chart, and a number of insights are immediately apparent. I do notice some element of seasonality. It seems in quarter 4, seats occupied tends to jump a little in quarter 4. So perhaps some seasonality. We see that someone smart was around back here because they predicted that spike in seats occupied and they added seats available. We also see that whenever seats are added to the route, so whenever seats available is increased, we see that the seats occupied tends to grow to fill those additional seats. So those are a few of the insights I'm thinking of, and they're interesting. What I see a lot of data scientists do is they come up with actually really great insights and feel like they have to get them all on the page. And in some situations, that's what the execs want. They just want to know everything. But in other situations, there's a time crunch, and you've just got to give the key takeaway. And often, you can dilute your message by including too many insights. And when you include too many insights, the big key thing that needs to get done can often get kind of pushed to the background. So remember, the chief operating officer wants to know, do we need to add additional flights to the route? So I'm starting to visualize my story coming together here. I'm seeing a new visualization, not a clustered bar, and we'll explain why not a clustered bar in a moment, with a big insight at the top saying, COO, you need to add this many seats to the route because of what we see in the visualization. So my story is starting to take shape. Okay. So we've talked about the audience. In reality, the data set obviously is not as sanitized and tiny as the one that I've got. So in the data storytelling work that I do, 80% of the time is spent cleaning and prepping the data, dealing with outliers. The other day we had a client who switched data warehouses in 2011 and lost 6 months of data. So that was a whole, we had to interpolate all the missing values and all of that. So obviously data is the fuel for your data story. Garbage in, garbage out. So having good data, that's key. We have a full 2-day course on this, and we teach how to get good data into your data story when you have issues like that. We've only got an hour today, so I'm not going to cover the data aspect. But do know it's 80% of the game. In this lecture, I'm going to focus more on the visuals and the narrative, because frankly, that's what I find more enjoyable. And I prefer talking about those things. Okay, so assuming our data is clean and good, the next step is to choose the right visual. And I always have one guiding principle in my head when I'm choosing the right visual, and that is to, above all else, show the data. This quote I've lifted from Edward Tufte. I'm sure many of you have come across Tufte in your data science perusals. And this guy, one of my personal heroes in data science, he's almost solely responsible for lifting up data visualization into being a sub-branch of statistics worthy of academic inquiry, with its own academic journals and its own body of empirical research around what makes a good visualization. He has a great book called The Quantitative Display of Visual Information. It's like a Bible, really thick. It goes right back into the origins of data visualization and the very first bar charts and pie charts. It's really interesting reading. But he spends about I'm exaggerating, but he almost spends a quarter of the book emphasizing this concept of, above all else, show the data. And we might think that's trivial. You might think, well, of course my chart shows the data. But some charts show the data better than others. I was in San Jose Airport, just coming out of Silicon Valley a couple of months ago, and I saw this chart on TV, and I just had to take a screenshot of it because I realized at that time, in my kind of 12 years as a statistician and data scientist, I had finally seen the worst graph of my life. This was live on air, okay? Now, it's obviously not showing the data. In fact, it's doing something worse. It's misleading with the data. So the shapes do not correspond whatsoever to the underlying numbers. Thank goodness they have labels. Let's talk about another chart that does not show the data. Here I have a 4-category pie chart. And I'd like to take a little bit of a vote There's no right or wrong answer because we're going to be dealing with perception here. I'd like to take a vote. Who feels that item C is bigger than item A? Yeah, a few votes. Thank you for voting. Who votes that item A is between 1 and 2 times bigger than item C? Yeah, a few votes. Thank you for voting. You guys are voting much better than Data Science Sydney last week. I mean, they were all really hesitant, so it's great to see. And who votes that item A is more than double as big as item C? Thank you for your vote. Thank you for your votes, guys. Okay, great. Still a bit of a data collection issue. A few people didn't vote. But let's move on to the next slide. To actually reveal what the true values are, we go to a 2D pie chart on the right, and we see that item A is more than double as big as item C. But we didn't even need to reveal the underlying numbers to conclude that that was a supremely ineffective display of data, because we all disagreed. Do you think if we had a 2D bar chart with a vertical bar for item C, 2D, and a vertical bar for item A, do you think we'd be disagreeing over what's larger? We would pretty much have a 100% consensus for those of us who aren't short-sighted. So, yes, we see that basically there's huge problems with 3D. I'm just going to skip ahead to another 3D chart here, just to put 3D to rest. How many females are earning $25,000 or more? So here's the red, 25,000 or more. I follow the axis up, and I see it looks like about 680, 690 or so females are earning 25,000 or more. I go to the 2D chart, and exactly 700, or maybe 699 females. So we were just completely misled by 3D and tilt. So 3D is dead. Let's have a moment of silence, everyone. It doesn't exist anymore. No, there are situations. Okay, if you have an XYZ plot, and R is really good at this. If you have an XYZ plot, I've used a package in R where it's been years since I used it, but you can make a 3D scatter plot that you can rotate around. And if you want that 3D view, that's a justification for 3D, right? But there's no need for 3D here. We have a bivariate axis, right? If I had a third axis, maybe. Okay, so Edward Tufte hates 3D and hates pie charts. Actually, he has a quote where he said, "The only thing worse than a pie chart is several of them." Which is one of my favorite quotes. Okay, so these things bothered him, and it's kind of okay now because good data visualization, data literacy is going up. So we see less of these abominations out there. Although I was at a data science conference the other day where someone was just going crazy with the 3D charts. But back in Tufte's time, in the 60s, 70s, and 80s, these were much more prevalent because data literacy wasn't as high. And this really bugged him. And so he decided to declare war on what he called junk charts. Okay, and he defines chart junk as anything on a chart or graph that is not necessary to comprehend the underlying message. So this wall over here is not needed. It kind of makes it look like a wedding cake. This shadow here is adding nothing to the message, and it simply just takes away from the key underlying message. So Edward Tufte declared war on chart junk, and when a statistician declares war on something, what do? Well, they invent a formula. So Edward Tufte invented a formula he calls the data to ink ratio. It's never a formula that you'd actually go and calculate. So don't go back and calculate the data to ink ratios of all of your charts. It's more a heuristic for thinking about data visualization. And it is equal to the amount of, the numerator is the amount of ink devoted to actually showing the data. So these would be your strokes, lines, axes, labels, the things that are needed, divided by the total ink that is used to produce the graphic. So this wall here, that is not data ink. This would add to the denominator of this formula, not the numerator. So this chart, just by eyeballing it, it probably has like 70-80% data ink ratio. Take a look at this chart. This has a very poor data to ink ratio. It has unnecessary vertical grid lines. The background of this slide is white, so you should just have a white background there. And so I'm going to wave my magic wand, give this chart a makeover, and there's the exact same data with an improved data to ink ratio. So as a guiding philosophy in your work, in your visualization work, think not what can I add to my chart, but what can I remove from my chart. Where a lot of companies go wrong, because I've seen companies, they give their visualizations to the graphic designer before putting them in publications and things like this. And that's almost the worst thing you can do, because the graphic designers almost always over-design the visualizations. Okay, so we want to seek high data ink ratio. The other concept I'm going to talk about here when it comes to good visualization design are these things called the Gestalt laws of visual perception. Anyone who's taken psychology has probably seen this before, because it's a bunch of psych research that has stood the test of time. But we're going to look at how these principles can help us tell better stories with data. And these rules were developed by a bunch of German psychologists in the 1920s. And there's 8 of them, and we're just going to cover a few of them today. So let's talk about the first Gestalt rule. The first rule is the rule of proximity. So in this group of dots over here, hands up if you see columns instead of rows. Okay, no votes, that's good. Hands up if you can see rows. Well, yeah, no need. Yes, thank you. Okay, so, and we see columns in the next group rather than rows, and we see 2 separate groups of dots rather than one contiguous blob of dots in the far right. And the reason for all of those takeaways that we see in each is because of the proximity of the dots. So in this group, the proximity row-wise is closer than the proximity column-wise. And the eye, all of this happens automatically. It's like the result of thousands of years of evolution, I guess. So this happens instantly. And what good data storytellers are doing today, on the fringe of kind of data storytelling nirvana, is we're using these Gestalt laws to force the reader to see things a certain way in our chart without resorting to things like arrows and labels and crude ways of highlighting certain aspects of the story. We're using these Gestalt laws, and it's quite spooky and mysterious the way it's done, but it works really well. So how can we use this Gestalt law of proximity? Well, back to our airline data, what I've done here is I've changed to a line chart instead of a bar chart. Why? Because the COO wants to know whether to add flights to the route. So the COO is concerned with a difference in magnitude. How much higher are seats available than seats occupied? I.e., are we getting, like, where we don't want to be is here, where we've probably left some revenue on the table here because the number of seats occupied was right up at full capacity. Okay, so these elbows here where we have this meeting of both time series, that's where we don't want to be. And so we kind of want to illustrate that we're on our way to that happening again, and we're trying to emphasize these gaps. Now, the line chart does that better than the clustered bar chart, because the line chart emphasizes differences between your time series, whereas the bar chart emphasizes the magnitude or height of your time series. So that's why I've changed to the line chart. The problem with the default graphs in Excel is that the legend is placed on the bottom. And when you place your legend on the bottom, and Excel gives you, the luxury of putting it on the top or the side, is that the eye has to do cognitive work to link each line to the label. You have to look up and down. So we're going to use the Gestalt law of proximity here to put the label right at the end of each time series. So we intuitively know that putting the label there kind of looks better. Well, to most people it would. And now we understand why. It's because of the Gestalt law of proximity. The proximity between that label and that line immediately forms an association in the brain that those two things are linked. And the brain can't escape that. It just happens automatically. The next Gestalt law I'll talk about is that of similarity. So in this group over here, we tend to see rows instead of columns. And in this group here, also we see rows instead of columns. I've delivered this talk a whole bunch of times in a few different countries. And sometimes there's been a few outlier people that kind of see columns there for some reason. You know, it does happen when your population is large enough. And here we see columns instead of rows because of the similarity of color. And so what we can do to make this association even more powerful is to have the same color as well. So now this legend right there is really beating the hell out of this legend here. So you can combine Gestalt laws to create very, very powerful associations in the brain. Okay, but we're not done yet. This is just a chart. This is not a data story. There's no narrative here. Okay. Before we go into adding the narrative, I'm going to talk about one last Gestalt law, and that's the law of enclosure. So over on the left here, we tend to see that the circles inside the enclosed box are together and are separate from these circles over here. We tend to see that the circles in the translucent egg here are together as opposed to the circles that are on the outside. And that's because they're enclosed. Things that are enclosed we see as being similar. So how can we use enclosure to make better charts? Well, one of the best applications of enclosure is to scatter plots. So with scatter plots, we often have a high volume of information. And they're just ripe for someone to come in and ask the chart, what is the story? And then use the Gestalt rules to clearly kind of hint to the reader what the story is. And we see that here. I turn to Robert De Niro to illustrate this point. And we have a scatter plot from Twitter user Chap Mangamo, who was very excited to see that I'd used this in the Data Science Sydney talk last week. He was just excited that such smart people, data scientists, were looking at his graph. But what we see here is a scatter plot. And I want you to imagine this scatter plot if it was just all black dots without the enclosures here. We have a blue enclosure and a red enclosure. And it's harder to get the message out. But Chap Mangamo, when he published this visualization, he had a caption that he put with it, which was, if you look really closely, you can see the exact year that Robert De Niro gave up. And the whole design of this visualization has been made to push that story home. So we have an upper blue enclosure here. We associate blue with good. He's sneakily, there's a few kind of low performances here, but so he's sneakily kind of created this blue enclosure there, and then the red enclosure here, and then our brain just says, that is, he was good, and then something happened, and there was a discrete, difference, and then he was bad. So that's this sort of enclosure shows, if we're looking at trend, the rectangular enclosure creates a discrete change point at age 59. Now, if I wanted to show that he gradually declined over time, okay, so, just imagining that as time went on, he gradually got worse every year, I would use a very different enclosure. I would use a I would use a diagonal ribbon enclosure. And so this is now emphasizing that as time goes on, he gradually gets worse and worse. Okay, so it's up to you as the storyteller to decide what enclosure am I going to use to tell the story that I want. For scatter plots, another really common one is quadrants. So the stereotypical example here is you've got risk and return for investments. Your bottom left, you might label low performing investments, and you've got your high risk, etc., etc. So do your scatter plot and think what is the most appropriate enclosure there. Okay. Okay, let's talk about the narrative. I turn to an example from Cole Nussbaumer. Cole is a ex-Googler who's very active in the data storytelling community. And I was mentioning that Edward Tufte's book is my Bible. Well, Cole's Storytelling with Data book is my second Bible. And I've got an example from Cole here. I recommend you go and get her book. It's excellent. I've got the reference down the bottom. And what we have here is data from a bunch of kids who were asked how they feel about doing science. Sort of like a clinical trial sort of thing. And so they were asked how they felt about doing science. Then there was an intervention. They might have been shown videos about how science has impacted mankind or how cool science is. And then after the intervention, they were asked, how do you feel about doing science? And we see that the number of kids who's excited has gone from 19% to 38%. But the question is a pie chart, two pie charts side by side, remember Edward Tufte had said the only thing worse than a pie chart is several of them. The question is a side-by-side pie chart the most appropriate display of this information? Does anyone have any ideas about what might be a more appropriate display?
Line chart.
Yeah, some form of line chart, absolutely. Okay, so what we're going to do is we're going to make over this chart with a more appropriate display of information, and we're going to add the narrative. So we've gone to a slope graph. What Cole's done here is just brilliant. So the first thing she's done is she's grayed out everything and used color very intentionally to bring what she wants to the front. Otherwise, everything is competing for prominence, when there might only be a few key interesting things in the chart. They've done research on grey versus black. So black is a bold color. It competes for prominence with all of your other colors. Grey, we tend to just push to the background. So one of the quickest ways to improve your visualizations is that. Start with grey, bring selected things to the front with color. Notice that in her narrative over here, she ties the narrative to the point on the chart that's relevant using the Gestalt law of similarity. Right, so then she's not cluttering up her chart with unsightly arrows and lines and all the garish ways we sometimes create associations. Incidentally, when we use an arrow to point to something, that is using a Gestalt law. It's the Gestalt law of connectedness, which we didn't cover here, which is a very strong law, but the negative of it is that you clutter up your chart, right? And we don't want to clutter up our charts. So she's added narrative. So this is a great makeover from Cole. But I want to ask, why is the slope graph so much better than the pie chart? All right, so we want to get scientific about this. If we understand the underlying processes about how the human mind works, we can tell better stories and not choose the wrong visualizations. And the reason the slope graph works so much better than the pie chart comes down to some research done by Cleveland and McGill in 1984. And they had a bunch of test humans and tested how they ranked various quantitative measures when they were displayed in different ways. So the first thing they looked at was position. Is this dot higher than this dot, or is this dot lower than this dot? And people were asked to also assess how different these things were. And then those human responses were compared to the underlying real numerical information. And it was found that when comparing positions, humans are really, really good at this. When comparing lengths, we're really, really good at this. And I have my own speculations about why this is so. It's like, okay, his spear is bigger than my spear. I'm worried, right? So we do length very well. We do angles okay. Is that angle bigger than that angle? Areas. So circular areas, square areas, areas of the slices of pies. It doesn't matter what area it is, we do terribly at comparing areas. So in some of the experiments, I read another paper where people were shown a pie slice size that was double as big as the other one, but people thought it was like 3 times or 4 times as big. Whereas if instead we'd used length, people are much more accurate, but still pretty horrible. That's why you want to consider labeling as well. Volumes, just terrible. And then color intensity, sometimes we have to, like in a choropleth map or something, but we do kind of badly at color as well. Okay, so that's the empirical research. So that's the science behind why this sucks. Okay, so going back to the Sydney to LA route, let's finally make over this chart. What I'm going to do here is, I'm going to do the story on 2 slides. So the first thing I've done here is I've created a projection of the numbers into the future. So that's kind of to show the COO, hey, here's the trend. Now obviously there's a lot of sophisticated methods that could be used for the projection. I've just kind of used a naive forecast where I took the last period's increase and extrapolated that out into the future. Just a quick and dirty forecast. Using dots to show that it's a forecast. And then on the next slide, showing that if we leave seats available at its current level, that if the seats occupied grows as is forecasted, there's going to be a shortfall here. And so what's really key is to emphasize the big takeaway. And the big takeaway is that we need to add more seats to this route. Now, obviously, if this was a real business scenario, we'd have to look at all sorts of things like what competitors are doing on that route and things like that, economic conditions and all of that. So this is more of a simplified example. But the key takeaway here is that instead of the bar chart, we've gone to the line chart. We're visualizing the future to get the COO scared about what's going to happen. And we're using the Gestalt principle of similarity of color here to tie the insight to the point on the chart that was relevant. And that's sort of a completed one slide data story. And it looks drastically different to our original exploratory analysis. But I see great data scientists who I respect a hell of a lot professionally for the predictive modeling and machine learning work that they do. And a lot of the time I see them produce visualizations that I know they could do better. Okay, so we want to do more of this sort of stuff and less of this sort of stuff. What we notice here was I sort of used a drill down effect here. So I started with this chart and then went to the final story. That's a decision for you to make as to whether your audience is ready to consume a multi-seried chart. Sometimes it can be good to start with this, talk about what's happened here, why we had that spike, and et cetera, and then introduce the second layer. As another example of layering, I've got a visualization here that I wanted to go through. Here we go. So I had the task of, I had to do a TED Talk last year, and I wanted to make the visualization engaging, but I had to present fairly complex data. And so I had to figure out a way to get all of the relationships on the page without overstimulating the audience. And of course, it was a TED audience, right? So it's not data scientists. I had to, kind of scale things back. If I did this again, I probably wouldn't use a donut chart. But anyway, that's what I chose. Edward Tufte would be not happy with this. But anyway, and so this visualization here is going to kind of illustrate this drill down effect. So what I did was I went to Google and I asked Google, I came up with a list of 500 important issues to humanity, what I thought were important. So, some of them are there: poverty, human rights, global warming, etc. But I fed a list of 500 different things into Google, and into Google Trends, and I got Google Trends to tell me what are the most Googled things. And this is what Google came up with. This is a D3 visualization, so we can hover over, and it tells us. I weighted the 5 things. Once it told me what the top 5 were, I then reweighted these to 100 and then assigned a popularity score to each. And so we see that people Google poverty almost twice as much as global warming. And that's interesting for humanity, that we just seem to, based on Google search behavior, in the English-speaking world at least, we seem to feel that poverty is double as important as global warming, at least based on search engine traffic. And we can add another layer. So for example, we can now drill down and see what people are searching for when they search for poverty. And so we can drill that right down. Okay. So I looked at this, and then what we did was we looked at these top 5 issues compared to the top 5 celebrities. So let's bring the celebrities in. So the top 5 celebrities have a popularity score of 87.43, and the top 5 global issues have a popularity score of 12.57. So like 7 to 8 times bigger. And so these really important celebrities, Kim Kardashian, Bieber, Miley, Taylor, and Beyonce, this has probably changed since I did this chart. Right, so there's probably someone new that's up there right now. I don't know who. I don't know, Wiz Khalifa or something. We can see that the drill down effect is just working really well here. So we can see what do people search for when they search for Kim and Bieber, etc. So, but if I jump straight to this in the TED Talk, it's too much information. So, and actually in the TED Talk, after the original visualization, I actually jumped to a visualization that was just this inner donut first, and then kind of suspensefully brought in the celebrities after that. So think about staging. Really easy to do in PowerPoint. Okay. Okay. So Dataseer, the company that I run, we do trainings all around the world. We have a full 2-day course on data storytelling. So if you watched this and thought, I think there's value in this, or I'd like to do better stories with my own data, we have a 2-day course running next week. We have another run of this course, May 15 and 16 as well. We're running it in Silicon Valley as well next in a couple of weeks, and also in Sydney. We have another course, Advanced Visualization and Dashboard Design. This is just a 1-day course. It's where we get into the less commonly used visualizations that, for whatever reason, haven't been included in most software packages, but they shouldn't be forgotten. So we cover those, and we also cover dashboards. How do we lay out dashboards in the right way? How do we select visualizations that are appropriate for dashboards? Third course, data science and machine learning in R and Azure. I was just talking earlier with a couple of people. We're not aligned with Microsoft at all, but as a data scientist, I'm personally quite impressed with the capabilities in Azure. So I've started to train in Azure just because it gives so much power to non-data scientists. But in this course, we introduce the data science process. I like thinking of data science as a process that, from collecting the data through to conceptualizing the problem, et cetera, and then we introduce machine learning and just cover some basic machine learning models like decision trees. And then the fourth course is predictive analytics and machine learning in R and Azure. This is where we get more in depth into machine learning, bagging, boosting, ensembling, neural nets, support vector machines, gradient boosting, and we go really in depth into those models that you'll need if you want to squeeze out good prediction error. And we look at how to tune those models. Sort of like, if you want to do well in Kaggle, you'd do this course. And then just a few shots of the training there. That was our Singapore run just the other week.